Yes, hello, can you hear me?
Yes, ma'am, we can hear you.
Anyway, I took your test in the previous class, but uh, I'll share the marks. You will get the report card from the office, but I'll have a discussion on it. And I'm just thinking, let me finish this chapter and then we will go back to the chapter, right? Okay. So we were doing exercise 7.1, right?
Yes, ma'am.
Okay, so up till 7th question we have done. This is the 8th question now. In the right triangle ABC, right angle at C. So this is a right, that means 90-degree angle. M is the midpoint of the hypotenuse, right? Now, which is hypotenuse? AB, correct? See this triangle ABC, right? This is A, B, and C. So in right triangle ABC, read the question, right triangle ABC, right angle at C. So this angle is 90-degree. M is the midpoint of hypotenuse. So this is M, correct? So M is the midpoint. That means it is given to you that AM is equal to BM. Understood? This is already given. Okay. C is joined to M, okay, and produced to D such that DM is equal to CM. So this is also given that DM is equal to CM. Okay. Prove point D is joined to B. Okay. Show that this. So first of all, you have to show that triangle AMC is congruent to triangle BMD, right? So we take these two triangles to show. See, you will write everything to show. Now, first part, that triangle AMC is congruent to triangle BMD, right? So take these two triangles. In triangle AMD, AMC, and triangle BMD. Let's say, what do we have? Now, where is AMC? Can you see in the figure where is AMC? AMC is this, right? Yes. And
Yes,
BMD?
ma'am.
BMD is this, right? So these two triangles I'm taking. Okay. Mm, see, something is given that the side AM is equal to BM, right? That means this side AM, sorry, wait, AM is equal to BM side. Clear? Okay. And this CM is equal to DM. This is also given, right? So two sides are given. Okay. So that means how many criteria do I have? I can use SAS, right? I can use ASA or I can use AAS. Understood?
Yes, yes.
Yeah. So two sides I have got. So that means this is like ruled out. Okay. Now let us see. Oh, again, two sides. That means this is also ruled out. So one angle has to be there, and that is the included angle. So do you think this angle is equal to this angle? Is this equal or not equal? If I call it
Yes,
1
ma'am.
and 2, why equal? Yes, Zeba. If I name this angle 1 and I name this angle 2, why they are equal? What is the reason? Jaslyn, why they are equal? At least say something.
Ma'am, because DM is equal to CM, so
Hmm. DM, see, DM is not equal to. No, no, you are confusing. If sides are equal, we cannot say angles are equal. See, this is a property you have studied in the chapter lines and angles. Remember, when two lines are cross each other, that means you see an X somewhere, right? So that means this angle is always equal to this angle. It is called vertically opposite. Remember it? So this angle 1 and angle 2 are vertically opposite angles. Similarly, this angle will be equal to this angle. Again, if I call it 3 and 4. So angle 1 is equal to angle 2, angle 3 is equal to angle 4. They are called vertically opposite angles. Remember all of you?
yes, ma'am.
Yeah, so whenever you have an X, please write it down. Write a sentence. Whenever we have an X, right, make a diagram. So these angles are called vertically opposite angles. Please note it down. So two sides are equal and the included angle. That means angle 1 is equal to angle 2. Why? Please write vertically opposite angles. This is given. This is also given. So this is a side, as you can see, this is a side and this is an angle. And this is an included angle. I mean, I'm taking this side and I'm taking this side. So the angle is coming in between. So this is SAS criteria. Understood? So by SAS criteria, triangle AMC is congruent to triangle BMD. Is this clear?
Yes, ma'am.
Okay. Now second part. So you have to show that angle DBC, where is DBC? That means this angle, right? Is a right angle. Okay, you have to show this. Mm. Okay, how we will do this? Now, second part is important. See how we will do it. So in your figure, I'm naming some angle. You also name it same. Otherwise, you will get confused. So this was my one angle and this was my two, right? This I'm calling 3, right? And this I'm calling 4. And this one is 5. And this one is 6. Is this understood?
Yes, ma'am.
Okay. Right. Hmm. Now, first of all, when I have shown that these two triangles are congruent, clear? So that means by CPCT, the other two angles are also same or also equal, right? In these
Yes.
two triangles, like this triangle is congruent to this triangle, right? And angle 1 was already equal to angle 2. That means the remaining angles are also equal. So triangle AMC is already congruent to triangle BMD. This we have shown, right? So by CPCT, that means corresponding part of congruent triangles, we can say that angle 3 is equal to angle 4, right? See, I'm not saying angle 3 is equal to angle 6. Why I'm not saying? Now please pay attention, because the side AM, it is given that the side, okay, it is given here, see here. The side DM is actually equal to this side, right? DM is not equal to AM, but DM is equal to CM. So that means when you are taking this angle, then you have to take this angle. Is this clear? So
Yes, ma'am.
angle 5 is equal to angle 6. So both I can say from CPCT. So 3 is equal to 4 and 5 is equal to 6. Is this understood?
Yes, ma'am.
Okay. Now, whenever you have like this, like you have two lines, correct? There's a transversal cutting it. Okay. If this angle is equal to this angle, that means if X angle is equal to Y angle, and this is your line L and M. So if angle X is equal to angle Y, and what kind of angle they are? As you can see, alternate interior angles, right? Right? So if alternate interior angles are equal, that means the lines are parallel. Is this understood, everyone?
Yes, ma'am.
See, this is the reverse situation. Okay. So this time it is given that the angles are equal. That means the lines are parallel. And if the lines are equal, that means the angles are equal. Sorry, if the lines are parallel, that means the angles are equal. Is this clear? Okay. So now you compare this situation with your problem here. If I just scroll it a little bit. Now see it like this. This is one line, right? And this is another line. Okay. This is your line, let's say DB, and this is your line AC. Is this clear? And if I just, let's say this is a transversal, right? Now, I've already shown that this angle is equal to this angle, correct? 3 and 4, right? So if angle 3 is already equal to angle 4, it means that the line DB is parallel to AC. Is this understood? Yes. Please respond yes and no. Zeba,
Yes, ma'am.
Zanab. Zanab,
Yes,
can you
ma'am.
hear me? Yes, right?
Yes.
Okay. So now how to write it? So I think the point is clear now. Now you write like this. So anyway, this was from CPCT we have shown, right? So now after this, we can say that since alternate interior angles are equal, right? So that implies the side AB is equal to, sorry, is parallel to side AB. No, sorry, not AB, AC. Wait. Yeah, AC and BD. Is this understood by everyone?
Yes, ma'am.
Okay. Now, because the two sides are parallel, right?
Yes, ma'am.
Okay. Now, try to understand one thing here. Again, there are so many concepts involved here. Now, see if the two lines are parallel, okay? And you join them like this from here. Okay, I should explain it in a bit detail. First of all, what is the definition of parallel line? Can anybody tell me? How do you define parallel lines?
The lines don't meet each other.
Will never meet each other. That means the distance between the line is always same, right?
Yes.
Yeah, it's always same. So in your figure, what is happening? It's like this. We have already shown that this line is parallel to this line. Clear? This is your AC and this is your BD. So we have already shown this thing. Okay. Now, because the lines are parallel, so this is the distance between them, right? And this is also the distance between them. So obviously, if this line is parallel to this line, then obviously this distance is also equal to this distance. Clear? So it's a parallelogram. Understood? This side is parallel to this side and this side is parallel to this side. Is this clear?
Yes.
Yes, ma'am.
Okay. So there's a property of a parallelogram that the consecutive angle, that means if you take this angle plus this angle, right? Or you take this angle plus this angle, like any consecutive angle you take, the sum is always is 180 degree, is supplementary. Is this clear?
Yes, ma'am.
Yeah. So if I take, so you write it like this, the lines are parallel, right? So that means angle B, no, not B, you write like this, angle DBC. Angle DBC plus angle ACB is equal to 180 degree. Why? Please write the reason. The reason is this, that consecutive angles, right, of a parallelogram are supplementary. Understood? Supplementary or 180 degree in the bracket, you can say, right? This is the reason, because already we have shown the lines are parallel. So that means this angle plus this angle will be equal to 180 degree. Is this understood by everyone? Okay.
Yes, ma'am.
Now one angle is already given, that it is 90 degree. Okay, you have to show. Sorry, it's not given. Yeah. Angle C is already given that it is 90 degree, because in the question it is written that in a right triangle ABC, clear? Right angle at C, right? So that means this angle ACB is already given, it is 90 degree. Is this clear? So angle DBC plus 90 degree is equal to 180 degree, clear? So angle DBC is 180 degree minus 90 degree. So the angle DBC is also equal to 90 degrees. So we have shown that angle DBC is a right angle. So we have proved the second part. Any confusion, anyone? See, there are at least three concepts involved here in this particular part only. One concept was only this, like congruency criteria, right? We have shown that it is congruent, then by CPCD the angles are equal, right? Now, because the angles are equal, then the lines are parallel. So I think this was the first concept we used. Then there was a second concept we used here. And then the third concept we have used here. Understood? That the consecutive
Yes.
angles of a parallelogram are supplementary. Okay, let us see the third part of this problem. One minute. Okay, so in the third part, what you have to show is to show that triangle DBC is congruent to triangle ACB. Okay, now where is DBC? First of all, see DBC. Can everybody see that? Right? This is DBC. Understood? You people never respond. So I'm taking like this triangle and then I'm taking this triangle, right? If I call it ACB and then this is DBC, just to make it clear, that's it. So these two triangles I'm taking. Let's see what is equal and what is not equal here. Can you see something equal in these two triangles? Can anybody tell me? Yes, Jocelyn, can you see something equal here? If I take these two triangles, is there something, some angle or some side which you can see is equal? Zainab,
BC.
yes, BC is a part of both the triangle, right?
Yes.
Okay, so at least BC I have got that BC is equal to BC. And yes, come on, Zeba. See, we have just shown that this angle is 90° in the second part, right? And this was already given that it is 90°. So at least one angle is 90°, each.
Yes, ma'am.
Okay. So like
And
angle B is equal to angle C. Okay, two things I have got. What is the third thing I can get here? Right, this side is common. Clear? Now this angle is equal. Is there any other side or any other angle which you can say is equal?
DB and AC,
DB and AC. Why?
90 degrees.
No, side. DB is side. It's not angle, right?
DC is equal to BA.
DC is BA, but it is not given in the question that they are equal.
The center N.
Yeah, but what is center M? There's no center because I'm taking these two triangles now. Look at the figure like this. I'm taking triangle this DBC, right? So there's no center here. Okay, now please see here. I have two triangles like this, right? Right? Can everybody see this?
Yes, ma'am.
So
Yes, ma'am.
yeah. So at least I need some sides which are equal. Now this side already I have got equal, right? Like it is common basically. BC is BC, same. Okay. Now there's nothing in the question about this side, right? So obviously this is ruled out. I cannot take this. Okay. And there is nothing in the question about these two angles. So obviously I have to leave this also. Now only this side is remaining. I can do something of this side. How I can do it? Now please see. I have already shown in the first part that these two triangles are congruent, like this triangle and this triangle, right? Yes. So can I say
Yes,
by
ma'am.
CPCT that this side is equal to this side?
Yes.
Yes. So I'll do this. So like we have already shown that triangle, what was the first part here? Triangle AMC is congruent to triangle BMP. We have already done this. So by CPCT, we will get AMC. That means AC is equal to DB. So this I got, right? Now you come to your triangle. So in triangle, this DBC and triangle this ACB. So let's see what do we have. So BC is equal to BC, which is common side. Okay, right? Now one angle is 90 degrees. So angle B is equal to angle C, which is 90 degree. Okay. And we will use this result first, that AC is equal to DB. Like from one, you can say. Clear? So which criteria is this? Now this is a side, this is an angle, this is a side. So which criteria? By SAS criteria. Okay, so these two triangles are congruent. So DBC is congruent to triangle ACB. Okay, now fourth part. Please see what is the fourth part. So in the fourth part, you have to prove this, that CM is equal to half of AB. This you have to show, right? Okay, no issues. CM, where is CM? Can you see CM in the figure and AB?
Yes.
Okay. Right. Now in these two triangles, which I have just considered, like this triangle, right? So this triangle and this triangle. Okay, this side was already common, right? This we have shown by, we have used the result 1. Now only this side is remaining, right? Only this side. Clear? So by CPCT we can make it equal. So these two triangles are already congruent. That triangle DBC is congruent to triangle ACB. We have just shown, right? So by CPCT I can say that the side AB is equal to side CD. Is this clear, everyone?
Yes.
Yes. Okay. Now I can break this CD because you can see here AB is already here. So I'm not going to touch AB. I'll keep this AB. So I'm going to break this CD because CD is not here, which I want to show. So I'll write AB is equal to, so CD can be written as CM plus MD, right? Yes. Yes. Okay. Now this can be written as CM plus CM. Why? Because M is the midpoint. That means both the parts are equal in length. Clear?
Yes.
That means CM is equal to MD. Okay. So your A, okay, this is AB. So AB is equal to twice of CM, right? And just take this 2 in the denominator. So half of AB is equal to CM. Proved. So please practice all the questions on your own, otherwise you will forget everything. Very little details are there in every question, I'm telling you. But if you will not note it down properly, you will forget it. Please write everything properly. Okay, done?
Done, ma'am.
Okay. So let us come to the next exercise. But before that, we have a theorem which we will use. Let us discuss it. So exercise 7.2, right? Okay. So far we have seen congruency criteria. Now there's a theorem. Please write it down. Angles opposite to equal sides of an isosceles triangle are equal. right? Now we will prove it. So basically we have an isosceles triangle, right? What is the theorem saying? So if we have an isosceles triangle, isosceles means that the two sides are equal in length, right? A, B, C. Okay, so what is given to me here? That ABC is an isosceles triangle. Clear? That means two sides are equal. So let's say AB is equal to AC. This is given. Okay. Then the theorem is saying that the angles opposite to equal sides. Now, which side is equal? This AB, right? Now, which is the angle opposite to it? Angle C. Clear? Right? Now, the other side is AC. The angle opposite to this side is this, angle B. So, if the sides are equal in length, that means angle C is equal to angle B. So, we have to show this thing. So, we have to show that angle C is equal to angle B. Clear? Okay. So, we will do one construction here, that we will just erase this part. Okay, so construction is this, that I'm drawing the bisector of angle A, right? So if I call it angle 1 and I call this angle 2. So construction is draw bisector of angle A. Bisector of angle A means angle 1 is equal to angle 2. Clear? Let's not write it here. This is just the construction. Let us do the proof. So basically why I have drawn this, if I call it D, because I need two triangles which I can show congruent, right? Because this was a single triangle. So at least I need two triangles if I want to use congruency criteria. So I have divided this into two parts. Clear? That's why I'm doing this construction. So let us take these two triangles. So in triangle BAD and triangle CAD, right? First of all, AD is common. AD is equal to AD, which is common, right? Okay. Now again, angle 1 is equal to angle 2, right? By construction, because I have constructed it this way that the angles are equal, right? AD is the bisector. That means angle 1 is equal to angle 2. So by construction, they are equal. And what is the third thing I can take? It is already given, it is an isosceles triangle. So this side is equal to this side, right? So AB is equal to AC, which is given. So which criteria is this? This is a side, this is an angle, this is a side. So by SAS criteria, triangle BAD is congruent to triangle CAD, right? Now if the two triangles are congruent, then by CPCT we can say that angle B is equal to angle C. Is this understood?
Yes, ma'am.
Okay. So if I just call it theorem, give it some name, any name. Theorem star, right? It's just a name. You can give any name to this theorem. Let's say this is my theorem star. So there's a converse of it also. Now we will see what is the converse. So this is converse of your theorem star. Converse means the reverse thing. So this time the angle is already given equal. That means the sides are equal, right? So the sides opposite to uh, equal, the sides opposite to equal angles of a triangle are equal. Now, what does it mean? So there's a triangle again, A, B, C, right? And if I again do the construction, that I draw the bisector of it and I call it D. So basically the sides opposite to equal angles. So this time it is already given that angle B is equal to angle C, right?
Yes, ma'am.
Okay. So the angles are equal. Angle B is equal to angle C. Now, which are the opposite side? So angle B means opposite side will be AC, clear? And angle C opposite side will be AB. So that means AC will be equal to AB, clear? But we have to show this. Understood?
Yes,
Okay,
ma'am.
let us show it same way. We do a construction that draw bisector of angle A. So if I just call it angle 1 and I call it angle 2, and right now take these two triangles again. So in triangle ABC, ABD, and triangle ACD, clear? Now,
Yes,
Jaslyn,
ma'am.
you tell me three things which are equal here.
Angle the AD, 9 AD
Yeah, AD
are
is equal to,
common.
yeah, AD is equal to AD, right?
AD
Okay, and is there any angle which is equal?
uh, angle 1 is equal to angle 2.
Yes, okay, which is by construction. Okay, and third thing,
AB is equal to AC.
you have to show that. Use the given condition, right? Something is given to you here.
BC.
No, angle B is equal to angle C. This is given, right?
Yes, ma'am.
That this angle is equal to this angle. So this is given. Now, which criteria is it? Okay, who will tell me which criteria is this? Zainab, which criteria is this? See, you can see a side, right? Then you have an angle, and this is also an angle. Which criteria is this? There are two angles and there is one side.
Side angle.
Hmm. How will I write it? Zainab, please say, which criteria is this?
Side angle.
Side, angle, and
AAS.
AAS. Okay, that's good. Okay, Zainab, I think I need to explain once again what are the different criteria, right? But anyway,
Yes.
first of all, finish this question. So this is AAS criteria. See, you have two angles and one side. So two angles and one side, right? AAS criteria. Okay. Triangle ABD is congruent to triangle ACD. So we have shown that this is congruent, and by CPCT, the sides are equal, right? Same thing we are doing, but this time Angle was given equal. In the previous part, side was already given equal. So by CPCT, we said angles are equal. Now in this part, angle is already equal. So by CPCT, we will say that the side is equal. Same process is there. Okay. So only the criteria will change. The congruency criteria will be different. Let me just quickly revise once more. What are the different congruency criteria? I think you people are struggling with it. Now see here. If you have, try to understand one thing, right? I'm drawing two triangles. So let me call it A, B, C, and let's call it P, Q, R. Now see here. First two are simple. Let's say all the three sides are equal, right? That means your side AB is equal to side PQ. Clear? This side is equal to this side. Then BC is equal to QR and AC is equal to PR. So if all the corresponding sides are equal, so this is simple SSS criteria. Understood? Yes?
Yes, ma'am.
Okay. Now the second one, let's say all the angles are equal. Simple. So I'm saying that angle A is equal to angle P, right? Angle B is equal to angle Q. Angle C is equal to angle R. But AAA is not in your syllabus, so just leave it. Just consider sides only, right? Let's say all the sides are equal. So simple SSS criteria. Any confusion? Yeah, this is simple. Now, there can be a possibility that, now try to understand, this is important here, and here you are getting confused. These are the two triangles, right? A, B, C, and this is another P, Q, R. Now try to understand what can be given to you. It is given that this side is equal to this side, right? So AB is equal to PQ, right, Zanab? Okay. Now this side is given BC is equal to QR. BC is equal to QR. Now, in place of the third side, one angle is given. Understood? So SSS means all the three sides are equal. But here, let's say two sides are equal and one angle is equal. So let's say this angle is equal to this angle, right? So angle B is equal to angle Q. Now, what is the location of this angle? See, the figure is like this. I'm considering this side and I'm considering this side, and the angle is falling in between, like this angle I'm taking. So I'm not taking the other angles, right? So this angle is called included angle. Understood? Included angle means it is like falling between the sides which I'm taking. So this becomes S, A, S criteria. So I'm writing A in the middle because it is the included angle. Understood? Zanab, please say yes or no.
Yes, ma'am.
Because I'm taking this side and I'm taking this side, and this angle is between the two sides. So this is called an included angle. So this is how I write this criteria, SAS, where two sides are equal and one angle is equal. Okay? Only this, only like this kind of angle is your in your syllabus. If I'm taking this angle or this angle, so just don't bother about it. That's not in your syllabus. Okay? So these two criteria are clear. Let's come to third criteria. Now, what can be the case? So this is my triangle, another triangle, ABC and PQR. Now this time, let's say two angles are given equal and one side is given equal, right? So let's say that this angle A is equal to angle Q. Okay. Okay. And one more angle is given. Let's say angle A is equal to angle P. All right, Zainab?
Yes, ma'am.
Okay. There can be two possibilities. Now same, I'll show you both. So these two angles are given. Okay. Now the third side. Now the side can be this. Now see here, I'm taking this angle and I'm taking this angle, right? So which side is like coming in between? This side, right? Clear? So if this side is equal, that means AB is equal to PQ. Understood? So this side is called included side. Please make the diagrams also. Included side. Understand? Because it is coming like between the two angles which I'm taking. It is the side, this side is there, common, right? So how we write it? We write A, then the included side and the other angle. This is called ASA criteria. Understand?
Yes, ma'am.
Okay. Now, if some other side is given, um, let's say this side is not given equal. Included side, anyway, you can mark it included side. Let's say it is given to me that these two angles are equal, right? That I have written here. Now let's say this side is given. So BC is equal to QR. Now as you can see, this BC and QR, they are not the included side, right, Zainab?
Yes, ma'am.
Yes. So how will I write it? So first of all, I'll write one angle, another angle, and then I'll write my side. This means this side is not the included side. So we call it AAS criteria. And if this side is the included side, we call it ASA criteria. I hope it's clear.
Yes, ma'am.
Yes. So one you have SSS. Okay. Then what was that? SAS, right? If there's one angle. Now, if there are two angles, so this means two sides, like at least two sides are there. And third can be side or third can be angle. Okay, now when you have two angles, so there can be two possibility, whether it can be ASA, whether it can be AAS. So I think this way it's better to remember, right?
Yes.
Yeah, so please like do it properly. So this is the third one and this is the fourth case. So four cases I've explained. Like at least two sides are there. So it will be either SSS or it will be SAS. So the third can be a side or the third can be an angle. So the included concept is clear. What is included side and what is included angle? See, this is a very minor thing. Mostly in schools, it is not even explained that properly. But I just want you to have a proper understanding of this concept because in class 10th you will be using all of this, and then I think no one is going to explain you that minute details, that what is an included side, what is an included angle, etc. Is this clear, Zainab, Jaslyn? Okay,
Yes, ma'am.
right. So now starts 7.2 exercise. Yeah, this is the question. In an isosceles triangle ABC, let us draw an isosceles triangle. A, B, C. Okay, so first of all, it is given that it is an isosceles triangle. Let us write down what is given. So AB is equal to AC. Clear? This thing is given with AB is equal to AC. The bisector of angle B and angle C intersect each other at O. So if I draw the bisector, that means I divide angle B into two equal parts. And similarly, I divide C into two equal parts. So these bisectors meet at a point O. Join A to O. So I also join A to O. Okay. Now show that. So you have to show OB is equal to OC, right? First part, you have to show OB is equal to OC. Let's see how we can do it. Mm, okay. Now see here, OB is this side, right? And OC is this side. Clear? So try to understand. Now, for example, I have a triangle like this, and this is your side O, B, and C, right? Okay. Now, if somehow I show that this angle is equal to this angle, if angle 1 is equal to angle 2, that I can use the converse theorem, right? Say yes or no. I have just told you a theorem, right? The converse is
Yes.
this, that if
Yes,
two
ma'am.
angles are equal, the opposite sides are also equal, right?
Yes, ma'am.
Okay. So my objective here is to show, first of all, that angle 1 is equal to angle 2. Understood? So let us see how we can do it. So let me give some name. This is my angle 1 and this is my angle 2. So I have to show they are equal, first of all. So I start from the given condition. This is my given condition, that AB is equal to AC. This is given. Now I can use theorem. Now because this side is equal to this side, that means angle C is equal to angle B. The opposite sides, opposite angles are equal. Clear?
Yes, ma'am.
Okay. AB is equal to AC. So I can say the opposite angle. So the opposite angle of AB is angle C and opposite angle of AC is angle B. So angle C is equal to angle B. Write the reason. Angles opposite to equal sides are equal. This is the theorem I'm using, right? That means half of angle C is equal to half of angle B, right? Okay. So half of angle C, that means angle 2, right? Because it is already given that OC is the bisector. That means this angle is same as this angle. Understood? So if I do half, so I can take angle 2, right? The angle C is divided into two equal parts. This is already given in the question. Is this clear?
Yes,
So
ma'am.
half of angle C is angle 2 and half of angle B is angle 1. So I have got the two angles which are equal. So the angles are equal. So that means I can say the opposite sides are equal, right? Now angle 2, the opposite side will be OB, right? And angle 1, the opposite side will be OC. What is the reason? That sides opposite to equal angles are equal. So I have shown it. Now second part. So you have to show. So you have to show that AO bisects angle A. So it was not given in the question that AO is the bisector, right? We simply joined it. So that means you have to show that angle 3 is equal to angle 4, right? Okay, how we will do it? So we can do one thing, like if somehow we show that this triangle is congruent to this triangle, if we show this, so by CPCT we can say that angle 3 is equal to angle 4, isn't it? Yes. So let us try to show these two triangles congruent. Okay. So if I take in triangle OBA and triangle OCA. Can everybody see where is OBA and OCA? The orange one in the figure, like this and this. Clear? Yeah, Zainab, can you tell me one thing which is equal here? Any particular angle or any side?
Angle 1 and 2.
But 1 and 2 are outside the two triangles, right?
3 and 4.
3 and 4, we have to show that they are equal. We have to show that AO is the bisector of angle A. That means angle 3 is equal to angle 4. We have to show. See, you have to look at either you have to look at angles or either you have to look at sides. That's it. Is there any side which is equal here? Always go to the given condition. What was given to you? See, you have to make use of what is given to you. In this question, it is given that it is an isosceles triangle, isn't it?
Yes.
Yes, isosceles triangle means AB is already equal to AC. It is given, isn't it?
Yes.
AB is equal to AC. This is given to you. See, you have to make use of the given things. Please, first of all, look at what is given to you in the question. Okay, what else? Is there any common side here?
Mm.
Jaslyn, is there any side which is common?
AB.
AB. AB is not a common side. AB is this side. How can it be common?
AC.
Come on. AC is this side. Is it a common side? Common means which is part of both the triangle. Common.
BC.
BC is even like out of the picture. I'm taking only these two orange triangles, right? Just forget BC.
AO.
Yes, very good. AO is equal to AO, right? It is part of both the triangles. Okay. So at least two sides I have got. So now third option, either I can show any other side which is equal or I have to take one angle which is equal, right? That's the only option. Already S I have got. Clear? Yes.
Yes, ma'am.
So either it can be SSS or either it can be SES. Understood? I have already got two S. So think of other side or think of any one angle. Is there any angle which is equal?
Angle 2 is equal to angle 1.
Angle 2 and angle 1 are outside the triangles which I'm taking.
Angle 3 and angle 4.
That I have to show. I have to show that AO is the bisector of angle A. That means I have to show that angle 3 is equal to angle 4.
AO, AO,
AO.
BO,
Hmm.
OC.
Very good. I have already proved it in the first part, right? So
Yes,
this
ma'am.
side is already equal to this side. So OB is equal to OC. like from part 1, you can say, right? We have already shown it. So all the three sides are equal. Which criteria is this? Come on, all the three sides are equal. SSS criteria, yes. So SSS criteria, the two triangles are congruent. So OBA is congruent to triangle OCA, right? Now, because the triangles are congruent, so by CPCT, all the angles are also equal, right? Right? Once the triangle are congruent, that means all the corresponding angles and all the corresponding sides are equal. So sides I've already taken. So all the other angles are equal. So by CPCT, I can say that angle 3 is equal to angle 4, right? Or we can say that AO is the bisector of angle A. Is this understood by everyone?
Yes, ma'am.
Yeah.
Yes, ma'am.
See, there is no point if I just keep on writing everything. So you have to respond in the class. So anyway, we will continue with the chapter in the next class now. And please revise everything what I have explained to you. Please come prepared in the class for the next question. Okay?
Ma'am,
Hmm.
my exams are starting from 23rd.
23rd. Okay.
Yes.
Zana, can you tell me the chapters which are coming?
Yes. Number systems,
Hmm.
coordinate geometry,
Okay.
and linear equations in two variables,
Okay. And
lines and angles,
okay. And
triangles,
right. Then
Heron's formula,
Heron's formula. Okay. And
and statistics.
oh, that's also coming. Heron's formula and statistics. Okay.
Yes.
Okay. So how many we have done now? Tell me. Number system we have done, right?
Yes.
Coordinate geometry.
Yes.
Okay. Linear equations. Done.
Yes.
Lines and angles.
Yes.
Okay. So triangle is going on. Anyway,
Yeah.
Heron's formula is a small chapter of one class. Only one class is required for it. So that we will do. And statistics, I think some part is deleted from your syllabus. Only hardly 1 or 2 exercises there. So, okay, I think we will wind up by 23rd. No problem.
Okay, ma'am.
Because we are already on second exercise of this triangle, right?
Yes.
And then one more exercise we have. So I think coming 2 classes, I hope we'll finish triangles. Okay. Okay, fine, Zainab. Jaslyn, are you also having exams soon?
Ma'am, I finished my half yearly. I don't know when I'll have the next one.
Okay. Please share the question paper. I think I also asked you that day. So if you have it, please share a picture with me.
Mm.
Okay.